I wrote a little Marimo app that can help you annotate data real quick. The app is called Bulk, and you can find it on Hugging Face Spaces if you're interested. And in this video, I'm first going to give you a demo, after which I am going to show you how I made this. So what you can do is you can drag and drop a file in here. It needs to be a CSV file that has a column called text. But in this case, I'm just going to use a default dataset, which is something you can also do if you just want to play around. We then see a spinner. First, some embeddings are being created. This step, by the way, can take a while. After that, we are running UMAP, and you'll see in a bit why. This is also somewhat slow, by the way. But once that is done, this interface appears. And this is an interface that allows us to do, quote-unquote, bulk labeling. The setup for all of this is that we take our text columns, we then pass that through transformer models that can generate embeddings for us. These are really big embeddings, by the way, with lots of dimensions. But what we can do is we can pass those embeddings through a dimensionality reduction technique called UMAP, and that will in turn give us two-dimensional embeddings. The cool thing about those is that you can easily plot them on a 2D plane, and UMAP in particular is pretty good at keeping the clusters intact. What's really nice about this is this will give us a 2D interface to interact with. We can actually try and make some selections of these clusters that we see over here, and we might be able to also attach a label there. And I have found that if you're interested in just bootstrapping some sort of classification task, that this bulk labeling technique is actually very pragmatic as a point to get started from. So let's properly use the app now. The first thing that you're going to want to do is set these label names. This side over here will give us a label that will be green in the plot, and this side over here will give us a label that is red. And the dataset that I'm using as a demo, by the way, is a spam dataset. So I would like the ham class, or the class that's not spam, I would like that to be green, and spam, let's make sure that's nice and red. Now, from here, what I can do is I can start making selections. I can start looking around and try and get an impression of where there might be clusters. And I seem to see a bit of a cluster down below over here. So the points that I've selected over here in the 2D space, well, there's text that's associated with it. So what I can do inside of Marimo is just render those at the bottom over here, and then I can get a bit of an impression of what the text is about. And just from glancing at this, this is SMS text data, by the way, and I remember back when I was in high school, you would get a lot of spam about ringtones, and it seems that what I've grabbed over here is indeed the ringtone cluster. So everything here seems to be about free ringtones. Although it's kind of hard to say if everything in here is spam, I do feel somewhat comfortable saying that a lot of what will be in here could be spam. So what I'm just going to go ahead and do is I'm going to scroll back up, and I'm just going to say, well, this cluster over here, let's just annotate that as spam. That now becomes red, and I can start exploring some other clusters. I selected another cluster over here that felt a bit pronounced, and this one is all about chances to win cash, or discounts, or last chance exclamation mark. So yeah, that also kind of feels like that might be spam. So this is already kind of nice and interesting. I'm able to make quick selections by exploring all these clusters, but there's a quicker way to explore this space as well. Because what I can also do is I can also use search. What that is going to allow me to do is that's going to allow me to compare all the texts that I've got, and in particular the embeddings that I've created for them. And I'm able to compare all of those embeddings with some sort of a embedding that comes out of some sort of a query that I can type in real time. I can then calculate some sort of a similarity, and then I can use the similarity to define the color of the point that you see over here. And here's what that would look like. So if I were to type something like, I don't know, you have won a prize, something like that, I can submit it. Then it seems to be the case that all the prize winning is happening in this segment over here. So I can also have a quick look. And yeah, just again from eyeballing, winner, exclamation point, urgent, you have won 1 week of free membership, £100,000 jackpot. So yeah, this also feels a bit spammy if you ask me, so I can also annotate this as spam. So we've got a bunch of spam now, and that's great, but maybe we should also look for something that's not spam. In particular, I figured, what's for dinner? That's kind of like a normal question you might ask your spouse or your roommate. And if I were to use this, then I see that there's a different cluster over here that really lights up. And indeed, if I have a look at the text examples over here, this indeed seems to be all about food, and I'm willing to make an assumption that this is all about normal food stuff. So that's probably not spam. If I were now to turn off this search option over here, then I get the normal colors which indicate which reasons have been labeled. And it definitely seems like we've got a couple of clusters over here that are on the spammy side, and I've also got a little bit of a cluster over here that's on the safe side of things. Now, the way to think about all of this is that, of course, we're not making a perfectly annotated dataset by doing this. What we're doing here is we're saving a whole bunch of time. I got these annotations only after a few minutes of exploring these embeddings, and if I were to scroll down, you can also see a counter. In a few minutes, it seems like I've gotten 500 labels that, even though they're not perfect, they might be pretty good for training a first machine learning model. The nice thing, by the way, about being able to train that one first machine learning model really quickly is that you can also use that machine learning model for active learning. One technique that you might want to consider is make some sort of a prediction with a machine learning model, and you can typically also get a confidence measure out. And if you get these probability values that are around 0.5, well, then those are maybe moments where the model is uncertain, and those could be interesting examples to annotate first as well. What I'm describing here, again, are all sorts of techniques to help you annotate quickly, and the goal in the beginning isn't so much to have perfect labels, but rather that you get the ball rolling and that you actually expose yourself to the training data in interesting ways. So again, this is on Hugging Face. You can play around with this if you want. But next up, what I figured would be good is maybe also talk a little bit about how this is made, because there's a couple of interesting techniques I'm using from Marimo that made it possible for me to implement this in an hour, maybe two. I'm running the same app locally now, and you can see the generated user interface over here. And maybe the first part that I would like to zoom in on is this Altair chart, because it's a little bit different. This Altair chart allows me to make selections, and when I do, I'm also able to update another cell. Another thing that's good to know, by the way, is that you can still click and drag. You just gotta hold Command or Control if you're on Windows. And when you do that, you should also be able to zoom. So that is something you can still definitely do here, but you get that extra selection behavior, quote unquote, for free if you use this one Marimo feature. And the feature that I'm talking about is this one. By wrapping a Altair chart with that one function, and this is especially true for scatter charts, you effectively get the same chart with extra behavior on top, with the goal of being able to make selections. That also means that this chart variable over here is something that will update the moment that the UI gets a new selection. And in this particular case, that means that whenever a new selection is made, I will update a data frame that is being rendered below, which is also something you saw in the demo just before. So that explains the selection mechanism inside of this chart, but there's some extra stuff happening as well. In particular, you're able to make these annotations. You're also able to undo something that happened before, and you're even able to download a JSON file with annotations. And if you think about the reactive nature of Marimo, this might come as a little bit of a surprise. After all, if you want to store these annotations, that means that you're going to have to keep track of some state. And in this particular case, it also means that we have to introduce a primitive from Marimo in order to get this to work. It's a little bit of an anti-pattern. Typically, if you want to write proper Marimo notebooks, you would try to avoid state as much as you possibly can. But in this case, because we really want to store the annotations that you're providing, there's also just kind of no way around it. So to facilitate this, we are going to be using this Marimo state feature. This is where I'm defining state, so to say. Whenever you define state in Marimo, you have to give it some sort of a variable to start out with. This is the default starting state, so to say. And then you will get two functions in return. There's one function that allows you to get the current state, and there's another function that allows you to set the current state. And if you're conscious on how you're using these two functions, you get a mechanism inside of Marimo that allows you to set some state here and there, while the rest of the app is still reactive. If you want to check all the nitty-gritty details, check this notebook yourself by checking the link in the show notes. But what I hope that you can imagine is that if you have these two functions available to you, that then the moment you hit a button that is supposed to add some annotations of a selection, that's the moment where this set label function is being used, and that is going to update some state. Then, if you were to maybe later download these annotations, then you would reuse this get label function instead, because that's going to give you the annotated state so far. And again, the state itself is not super complex in this case. I'm just keeping track of my positive labels as well as my negative ones. But I mainly hope it's clear that we need some sort of mechanism here to deal with this state. And it's also fair to say this is a relatively advanced feature of Marimo. And if you're doing standard data work where you're exploring, let's say, a data frame or two, then it's also a feature that you probably wouldn't want to use anyway. But for more advanced apps, this state object can be quite useful. So there you have it. This is a bulk labeling tool that you can use for your own dataset. It's also a little app that's live, so definitely feel free to use this and to learn from this. But I do want to hint at the next video that I'll be making, which is going to discuss how to maybe speed this up a bit. Because right now, what we got to do is we got to take all of our texts and we have to embed that somehow. And this embedding is typically something that is computationally quite expensive. And quite frankly, the UMAP algorithm, it's great, but it also tends to be just a little bit slow. So in the next video, we're going to look at a technique that is going to speed up our embedding. And we're also going to look at an alternative user interface that might still allow us to annotate quite quickly, but in a way that we can get started right away.